Trigonometry can be used to find the length of an unknown side or angle in a right-angled triangle. Let's consider a right-angled triangle A, B, and C, which is right-angled at point A. The angle under consideration is theta. This is the angle under consideration. Now, where B is facing is called small letter B. This is the side of B. Where A is facing is called small letter A. This is the side of A. And where C is facing is called small letter C, which is the side of C. So all we just want to know about trigonometry is that it is used to find the length of an unknown side or angle in a right-angled triangle. So we apply trigonometry to find the length of angles and sides in a right-angled triangle. The triangle must be a right-angled triangle. The side where angle 90 is facing, please note, where angle 90 is always facing is called the hypotenuse, and it is the longest side in a right-angled triangle. Please take note of this. Where angle 90 degrees or where the right-angled triangle is facing is always called the hypotenuse, and it is the longest side in the right-angled triangle. It can also be called our small a. The side opposite the angle under consideration, the angle under consideration in this diagram is angle theta. So the side facing the angle under consideration is always called the opposite. Please take note. The side facing the angle under consideration is just like the side opposite. Okay, they are opposite. The side facing the angle under consideration is called the opposite. And if you can see, it is labeled small letter B. Now, the side that is next to the angle under consideration. The angle under consideration, remember, it is angle theta. So the side next to the angle under consideration is called the adjacent. So the adjacent is always the side next to the angle under consideration, and it is labeled small letter C. Please take note of all these parameters because we are going to use it to solve problems. What if I change the direction of this angle? Instead of the angle being at point B, I can decide to place the angle at point C. So if the angle under consideration now becomes alpha at point C, where will our hypotenuse be? Always note that where the right angle triangle is facing, or where the right angle is facing, is always called the hypotenuse. No matter how the angle under consideration is being changed, where the right angle triangle is facing is always called the hypotenuse. Now, if you look at this angle under consideration again, the side opposite the angle under consideration, remember the angle under consideration here is alpha. So the side opposite the angle under consideration is called our opposite. The side where the angle under consideration is facing is called our opposite. Please take note of that. Irrespective of where the angle under consideration is, where it is facing is called the opposite. And our opposite, according to this diagram, is small letter C. Now, the side close to the angle under consideration is called the adjacent. It is called the adjacent. So the side close to the angle under consideration is always called the adjacent. So this is what we have. So despite the arrangement of the angle under consideration, just note that where angle 90 is facing is called the hypotenuse, which is the longest side in this right angle triangle. Where the angle under consideration is facing is called the opposite, and the side close to the angle under consideration is called the adjacent. Now, when considering a right angle triangle, I want us to know that the acronym Sohcahtoa will be used throughout this course. Please note that this acronym is very useful, and it will continue to be useful throughout this lesson. Sohcahtoa. I believe you've heard this acronym before in your junior secondary. Now, what does this acronym Sohcahtoa really mean? The So simply means opposite over hypotenuse. The So simply means sine equal to opposite over hypotenuse. So the S is the sine. We don't normally put the E. Sine equal to opposite over hypotenuse. Then the car, which is the CAH, the car simply means cosine or cos equal to adjacent over hypotenuse. The short form of cosine is cos. Cos equal to adjacent over hypotenuse. Then the toa, which is the TOA, which simply means tangent or tan equal to opposite over adjacent. So please note these acronyms because we are going to use it to solve relevant problems concerning a right angled triangle. Given this right angled triangle, which is right angled at point A, the angle of C is alpha, the angle of B is theta. I want us to fill in sine theta, cos theta, tan theta, sine alpha, cos alpha, and tan alpha. Now I want us to fill in the values of this. How are we going to do it? The first thing that we must know is that we are going to use the acronym Sohcahtoa. This acronym will help us to fill in these missing values. Remember, the angle under consideration here is theta, while the angle under consideration here is alpha. Now, since we are asked to find sine theta, we use the So because S simply means sine. The So means opposite over hypotenuse. Opposite over hypotenuse. And our opposite, according to this diagram, is B, small letter B, while the hypotenuse is small letter A. So since we have known our SO to be opposite over hypotenuse, we are going to substitute B and A. So we'll substitute into this. Sine theta is equal to, we said it is opposite over hypotenuse, so our opposite is B, while our hypotenuse is A. So we are done filling sine theta. So sine theta is equal to B over A. Remember, the angle under consideration here is theta. Now let's look at cos theta. Let's look at cos theta. How are we going to fill up for cos theta? Since we are asked to find cos theta, the acronym we are going to use here is the CAR. The acronym we are going to use is the CAR. Now, what does CAR simply mean? CAR simply means adjacent over hypotenuse. Remember, the angle under consideration is theta. So if theta is the angle under consideration, our adjacent will be the side close or closest to the angle, which is small letter C. This is our adjacent. Then our hypotenuse is where our right angle triangle is facing, which is small letter A. So let us substitute. In substituting, since we are having adjacent and our adjacent based on the angle under consideration, which is theta, is C, over our hypotenuse is small letter A. So we are having cos theta is equal to C over A. Now the next one we are going to fill up is tan theta. How do we locate tan theta? Since we are asked to find tan theta, we use the acronym TOA. So what do we mean by TOA? Just know that T simply means tangent and the angle under consideration is still theta. So TOA simply means opposite over adjacent. So our TOA simply means opposite over adjacent. And based on this diagram, our opposite is small letter B, while our adjacent is small letter C. So let us fill it into the missing bracket. To fill this in, our opposite, we said our opposite is small letter B. Opposite is small letter B, while our adjacent is small letter C. So we have filled all these parameters. You can pause the video and try to fill up the remaining three using the angle under consideration here as alpha. So if alpha is the angle under consideration, try to fill up the remaining three. Let's see what you have. So what is sine alpha? Since the angle under consideration is alpha, sine is opposite over hypotenuse. So our opposite is small letter C. Opposite is small letter C. Our hypotenuse is small letter A. What is cos alpha? Cos simply means adjacent over hypotenuse. So our adjacent is small letter B. Since we are considering alpha, adjacent is small letter B, hypotenuse still remains small letter A. Now what is TOA, which is tan equal to opposite over adjacent. Opposite over adjacent. So if this is the angle under consideration, our opposite is C. So you're having small letter c over our adjacent is B, which is small letter b. Now, since we have filled up all these parameters, if you solve the correct thing, you are going to get sine alpha equal to C over A, cos alpha is equal to B over A, while tan alpha is equal to C over B. Now let's see how we can solve some examples using the acronym Sohcahtoa. We are given this side to be 4 centimeters. We are given this side to be 5 centimeters. And the angle given to us is theta. Remember, this triangle is a right angled triangle which is right angled at point A. Now we are asked to find theta. Before we can solve for theta, the first thing you have to do is to ask yourself, what is the angle under consideration? Now, based on this diagram, the angle under consideration is theta. Since theta is the angle under consideration, the next question you are going to ask yourself will be, how do I determine my opposite? How do I determine my adjacent? And how do I determine my hypotenuse? Please take note, where the right angle is facing is called the hypotenuse. Where the right angle is facing is always called the hypotenuse. Now, since we have established that fact, where is our opposite? Remember, the angle under consideration here is theta. So our opposite will be where angle theta is facing is called the opposite. Where angle theta is facing is called our opposite. Please take note of this. Always know that anywhere the given angle is facing, the angle under consideration, wherever the angle under consideration is facing, is always called the opposite. So the side close to the given angle is called the adjacent. Since we have named all the sides, opposite, hypotenuse, and adjacent, the next thing we are going to do will be to write out our acronym, which we have done here, Sohcahtoa. Now, since opposite and hypotenuse are known, they are given. Opposite is 4 centimeters, hypotenuse is 5 centimeters. Since opposite and hypotenuse are given, we are going to use SO, which is sine theta equal to opposite over hypotenuse. So we are going to put opposite over hypotenuse. Sine theta equal to opposite over hypotenuse. And we know our opposite to be 4 centimeters. We know our hypotenuse to be 5 centimeters. So we are going to fix in those given sides into that parameter. So we are having opposite to be 4 centimeters and hypotenuse to be 5 centimeters. So we're having sine theta equal to 4 over 5. Now 4 over 5 is the same thing as 0.8. So sine theta is equal to 0.8. Since we have gotten sine theta equal to 0.8, we are asked to find theta, not sine theta. So whenever you arrive at this point, to find theta, you are going to find the sine inverse of this value. You can get it with your calculator. You are going to get the sine inverse of 0.8. So the sine inverse of 0.8, if you get it rightly, will be 53.1 degrees. Please, when solving, since theta is an angle, don't forget to put your degrees. Very, very important. So we are having 53.1 degrees. So whenever you are given this kind of problem, try as much as you can to follow the steps. The first thing you do is to find out the angle under consideration. If you have known the angle under consideration, it will help you to know where your opposite, adjacent, and hypotenuse is. When you have located your opposite, hypotenuse, and adjacent, then you write down the acronym Sohcahtoa. Please make sure that out of these three parameters, that is SOH or CAH or TOA, out of any of these three parameters, if we are using the SO, we must make sure that at least 2 out of 3 of the parameters are known before we can use it. Now, if you look at the car, the reason why we did not use car, which is cosine theta equal to adjacent over hypotenuse, is because we don't know our theta. We don't know our adjacent. We only know hypotenuse. Since we know only one parameter here, it cannot help us to find for the value of theta. We did not use the toa again because tan theta, theta is not known, opposite is known, but adjacent is not known. So we only know our opposite here, but we must know 2 out of the 3 parameters. Therefore, we did not use toa. I had to use so because opposite is known, hypotenuse is also known. So when you have identified which of these to use, then you substitute, then find the sine inverse or cosine inverse or tan inverse as the case might be. Let's look at another example to explain this further. In this example, we are asked to calculate PR, PR. We are also asked to calculate RS, which is Y. RS was labeled Y in the figure below, and the final answer we should correct to 3 significant figures. Now, as we solve this problem, I want us to realize that we are having 2 triangles in one. We are having 2 triangles in one. What are the triangles? The first triangle is triangle PQR. This is the first triangle we are having in this diagram, and it is right angled at point R. This triangle is right angled at point R, we have another triangle, that is the second triangle, and it is triangle PRS. This is the second triangle, triangle PRS, which is right angled at point S. This triangle is right angled at point S. Now, given these two triangles, we are asked to find PR. This is the side of PR. How do we find PR? Now, these two triangles is having something in common, which is PR. Side PR is in the first triangle, and side PR is also in the second triangle. If I separate these two triangles, this is what I'm going to have. Now, the first triangle is triangle PQR as stated earlier, while the second triangle is triangle PRS, because PR is common to both sides. PR is common to both triangles. Now, we are asked to find PR. The first triangle is having PR. Second triangle is having PR. Which of these triangles are we going to use to solve side PR? We cannot use this triangle here because there is no side given. We are only given an angle. If you want to use Sohcahtoa, if you are using the so is opposite over hypotenuse. Opposite is not given. Hypotenuse is not also given. So you cannot use so. You can't use car because in fact there is no side given in the second triangle. But in this first triangle, side QR is given. So we have at least two parameters. We have an angle and a side. So this is the triangle we are going to use to solve for side PR. Now, in order to solve for side PR, we are going to label the side we are looking for X. Please look at these two diagrams again. I got this second diagram out of the first diagram. So to solve for side PR, we are going to label the side we are looking for X. So after you have labeled the side you are looking for X, the next thing we are going to do is to fix in our parameters. Where is our opposite? Where is our adjacent? Where is our hypotenuse? This will be our focus, because you cannot solve for side X without knowing where your opposite is, without knowing where your adjacent is, and without knowing where your hypotenuse is. Please, if you label these three wrongly, you are going to get a wrong answer. So the first thing to do is to try to label the sides. Now let's see how we can label the three sides. Where the right angle is facing is called the hypotenuse. Where the given angle is facing is called the opposite, and the other side is called the adjacent. Now, since we have labeled all the three sides, the next thing we are going to do will be to apply the formula Sohcahtoa. In applying the formula Sohcahtoa, I want us to know that since we have known all the three sides, to apply this formula Sohcahtoa, we cannot use the car because there is no opposite here. We are asked to find opposite. Since opposite is not included here, we can't use it. Despite the fact that there is opposite here, since hypotenuse was not given, we don't know hypotenuse, so we cannot also use the so. Please note, the reason why we are not using so despite the fact that there is opposite is because we don't know our hypotenuse and we don't know our opposite. Remember, I told you that you can only use an acronym if and only if 2 out of 3 of the parameters are known. We don't know opposite, we don't know hypotenuse, so we cannot use this. There is no opposite here since we are asked to look for x and x is our opposite. There is no opposite here, so we cannot also use car. So automatically what we are going to use is the toa, which is the tan, opposite and adjacent. Opposite is not given, that is what we are looking for. We know our adjacent to be 6 centimeters and we know our angle to be 50 degrees. Now, since we have known 2 out of these 3 parameters, automatically we are going to use that to solve for the problem we want to solve. In solving this problem, since we are using the toa, so it becomes tan. Our angle is 50 degrees. So tan 50 degrees is equal to opposite over adjacent. Opposite over adjacent is equal to opposite over adjacent. So since tan 50 degrees is equal to opposite over adjacent, we know our opposite as x. We know our adjacent as 6 centimeters. We are asked to find opposite, which is x, but our adjacent is 6 centimeters. So we are going to substitute. Wherever we see opposite here, we put x. Wherever we see adjacent here, we put 6 centimeters. So we are having x over 6. Now, since we have tan 50 equal to x over 6, the next thing we are going to do here will be to cross multiply to solve for the value of x. So if you cross multiply this here, it becomes 6 times tan 50 degrees equal to x. If you can confirm, tan 50 degrees is 1.192. So we substitute, it becomes 6 times 1.192. So if you multiply these two, the value for x you are going to get will be equal to 7.152. 7.152. But since we are asked to correct our answer to 3 significant figures, so our answer will be 7.15. 7.15. Remember, if you want to change to 3 significant figures, this is the first, second, third. The next number is not up to 5. So you round down, so it becomes 7.15 centimeters. Since we have gotten PR to be 7.15 centimeters, I can replace it back into this diagram. So PR is 7.15 centimeters. The second question says find RS. We are asked to find RS, which is Y. How do we look for RS? Now, to simplify this work, I want to remove triangle PRS from this diagram. So in doing so, I have these two diagrams, triangle PRS. So I removed this triangle from the original triangle. So let us focus on this since we are looking for Y. Now, how do we solve for Y? Remember, our hypotenuse is given to be 7.15 centimeters. Our opposite is what we are looking for. We don't know adjacent. So which acronym are we going to use to solve this problem? We are having the acronym Sohcahtoa. Which of these acronyms can we use to solve for Y? Now let's look at the TOA. Can we use the TOA to solve for Y? TOA simply means opposite over adjacent. Opposite is what we are looking for. We don't know opposite. We don't know adjacent. So since two parameters are unknown, we cannot use the TOA. Let's look at the car. Adjacent is unknown. We don't know adjacent. Hypotenuse is known. We know hypotenuse to be 7.15 centimeters. But since what we are looking for, which is the opposite, is not found in car, we cannot still use car. There is no opposite, no O in car, so we can't use car. Automatically, the only acronym we can use here will be our SOH, S-O-H. So how do we solve for that? It becomes sine 28 degrees, sine 28 degrees equal to opposite over hypotenuse. So what is our opposite? Our opposite is what we are looking for, which is Y. What is hypotenuse? Hypotenuse is what we have found to be 7.15 centimeters. So we are going to substitute. Anywhere we see opposite, we put Y. Wherever we see hypotenuse, we put 7.15 centimeters. So we are having Y over hypotenuse is 7.15. Now, to find for the value of Y, we'll cross multiply. So sine 28 will multiply 7.15. So it becomes 7.15 times sine 28. Now to find Y, we are going to simplify this. What is sine 28? Sine 28 is 0.469. So it becomes 7.15 times 0.469. 0.469. Let's just put the whole value. 0.46947 equal to Y. Now to solve for the value of Y here, we multiply 7.15 by 0.46947. So if you multiply, your value for Y will be equal to 3.356. But since we are asked to express our answer to three significant figures, it becomes 3.36 centimeters. So the value for Y is 3.36 centimeters.